Welcome to the viewers. Now we discuss how to calculate inverse of a matrix. For this we first require to calculate adjacent of a matrix. But now we at first needed to calculate the adjacent of a matrix. We needed the concept of cofactor. What cofactor is? Cofactor is minor with the proper sign is called cofactor. And we first calculate the cofactor. Then we calculate adjacent of a matrix. After that we calculate inverse of a matrix. And one criteria must be needed. Inverse of a matrix when we are calculating, this matrix must be non-singular. That means determinant of this matrix must be non-zero. And another criteria is matrix must be square matrix. Otherwise it is not possible to calculate any type of inverse of a matrix. Now how to calculate it? Let's take a look. We calculate cofactor. Let us consider a matrix A is equal to this matrix A11, A12, A21, A23, A33. And now the cofactor of A11. Here we already to calculate the cofactor. So we have calculating here for the cofactor of A11, row and column wise. If we make it intersection row and column, all remaining elements will be A22, A23, A32 and A33. Writing in this way, and this will be the determinant. And to calculate the sign, it will be applied by the formula -1 whole to the power I plus j. That means position of the element. Positions means I jth element. Here first row, first column. So it will be 1 plus 1. Clear? It was 1 plus 1. So it will be positive term. -1 whole to the power 2. We are taking in this way. And now we calculate A12. -1 position of the second term. So intersection of row and column. All other elements will be, remaining element will be A21, A23, A31, A33. Put in the determinant form. And -1 whole to the power 1 plus 2. That will be negative. And now we calculate A13. -1 whole to the power 1 plus 3. All the remaining element will be intersection of row and column. Remaining element will be A21, A22, A31, A32. And for it will be positive. -1 whole to the power 1 plus 3. Now we calculate A21 -1 whole to the power 2 plus 1. Similarly, A21 intersection of row column. Remaining element will be A12, A13, A2, A31 and A32. Putting in this way. So in this way we calculate the all cofactors. Now left as an exercise to calculate A22, A23, A32, A32, A31, A32 and A33. Let's consider the matrix A is equal to A11, A12, A13, A21, A22, A23 and A33. We calculate adjacent of A. Therefore, for the cofactor we are writing A11 corresponding to the element A11, A12 corresponding to the element A12 in this way, and its transpose by definition. Transpose of this all cofactors. It is property. So it will be row is changed to the column A11, A12, A13, A21, A22, A23 and A31, A32, A33 in this way. And now we calculate the inverse of the matrix. Now we calculate A inverse. By definitions of A inverse is equal to adjoint A by determinant A. It will be 1 by determinant A. And one more things to be added here. This matrix A must be non-singular. That is, determinant A is not equals to 0. If determinant of any matrix is non-zero, then we called it as non-singular matrix. So here determinant A non-zero. Otherwise inverse does not exist. So it will be 1 by determinant A, and 1 by determinant A, A11, A, we are writing all this element of adjoint as we find earlier stage. Write all these elements and included 1 by determinant A. That is multiplied by, this is a scalar quantity, so multiply all the elements. We will finally get this result, and with determinant A not equals to 0. Now this will be the final inverse of A. So A inverse by definition adjoint A by determinant A. So in this find all the calculations of A inverse. And now in the ideas, we give some of the ideas, hints about how to calculate the determinant, and if we find few examples, that will be better of understanding. Here the idea, let us consider an example. If A is equal to AB, a matrix of square matrix, and it will be the elements of the matrix are 0, -1, 1, 1, 0, 2 and 3, 3, 7. Then at first we calculate determinant of A, and it's clear, general expansion of determinant. If we intersection of row and column 0 into of the determinant 0, 2, 3, 7 row wise, and minus minus plus expansion, general expansion 1, 2, 3, 7 and 1, it is 1, 0 and 3, 3, and finally we find 0, 7 minus 6, that is 1, and 1 into 3 minus 0, that is 0, that is 1 plus 3, that is 4. So it is A is a non-singular matrix, and since A is non-singular matrix, so A inverse exists. So therefore A inverse by definition adjoint A by determinant A. Now we calculate adjoint A by determinant A. We write adjoint A by determinant A equals to 1 by determinant A, and giving the formula of adjoint of A, that will be intersection of row and column for 0, that is 0, 2, determinant of 0, 2 and 3, 7, right, 0, 2 and 3, 7. Next element minus 1, intersection of row and column, we write in the remaining element will be 1, 2 and 3, 7, that will write in the column wise 1, 2, 3, 7, and minor with proper sign. This position of the second term, that is negative, that's why it is negative. And next for 1, 3, that will be position in 3, 1 element. 1, 3 will be intersection of row and column 1, 0, 3, 3. Writing in this way 1, 0, 3, 3. It will be positive because minus 1 whole to the power 1 plus 3, that is plus. And similarly for alternating sign, that's come usually in cases of adjoint of any matrix. So minus, and next element will be 1. So intersection of row and column, it will be remaining element will be minus 1, 1, 3, 7. Writing in this way minus 1, 3, 7. Then for 0, intersecting element of row column, remaining element will be 0, 1 and 3, 7. That will be 0, 1 and 3, 7. Positive sign obviously. And next will alternating sign will be negative of for 2, that will be 0, minus 1, 3, 3, and 0, minus 1, 3, 3 column wise. Next for 3, it will be the intersecting element of row column, remaining element will be minus 1, 1, 0, 2. So it will be minus 1, 1, minus 1, 1 and 0, 2. Next element for 3, it will be 0, 1, 1, 2, or negative sign 0, 1, 1, 2. And last element for 7, intersection of row and column, the remaining element will be 0, minus 1, 1, 0, 0, minus 1, 1, 0. Then expansion, it will be 0, minus 6, it will be minus 7, minus 3, that is minus 10, minus of minus 10 plus 10, it will be minus 2, 0, that is minus 2, 7 minus 6, that is 1, so it will be minus 1, 0 minus 3, that is minus 3, it will be 0 minus 1, minus of minus 1 plus 1, it will be 3, it will be 0 plus 3, that is minus 3, and 0 plus 1, that is 1. So in this way we calculate, and 1 by determinant we already calculate the value, that is 4. So 1 by 4 of this will be the inverse of the matrix, and we give the examples with the help of example to clear the idea. Now we end our discussion today. If you like this video, like it, share it, and don't forget to subscribe the channel. Thank you.